All right, as you can see already from this chapter, there's going to be a lot of factoring, and it's really important that you know how to factor, because if you don't know how to factor moving forward, it's going to be really difficult. And I know we've been doing a lot of factoring in chapter 3, where we had a leading coefficient of 1, but there's going to be times in this chapter where the leading coefficient is not 1. So we want to make sure that you remember how to do that. So we put together just one day just to make sure that everybody's on the same page, starting with some basic ones and working our way up with how to factor. Because again, all of these, it's really important to make sure you know how to factor effectively. Because if you don't, it's going to really put you in a bad spot for this chapter in particular. So starting out with this first one. So this first one, you might at first think, well, maybe this is a difference of squares because we have an x squared. Well, remember your first step, anytime we go to factor anything, should always be to look to see if there's a greatest common factor. Now, I see with this one that we have, both terms have at least an x, so I'm going to factor an x out. But then I also see that they both end in 0, so 10 would go into both of these. But you want to make sure that you're looking for the greatest common factor. I always like to just start with the biggest number, or not the biggest, the smallest number that we have, and see if that goes evenly into both of the numbers. And sure enough, 40 goes into both 40 and it goes into 120. So we're going to start by factoring out a 40x. Now when I do that, I'm dividing everything again by 40x. So 40 divided by 40 would be 1, and if we factor out an x from x squared, we're left with 1x, or you can just say x. Now the next is going to be minus, and 120 divided by 40 would be 3. And if I factor an x out, I'm left with just y. Now you want to make sure you always factor completely. Now this x minus 3y is not a difference of squares or anything like that. There's nothing more I can factor out from that. So this would be my final answer for this first one. So this is just, for this first one, we're just reviewing how to basically factor out a greatest common factor. By the way, just a little note here. When you factor out a greatest common factor, if you start out with 2 terms, you will always end up with 2 terms. Okay, you'll never end up with less terms than what we started out with. And the reason why I say that is, let's say if these both had an x squared, and we factored out an 40x squared, that does not mean that the 40x squared goes away. That just means we would have had just a 1 left over. So I always say that, or I want to point that out, because there are times where I see students do something like that and they have less terms in parentheses than what they start out with. And that should never happen when we're factoring out a greatest common factor. All right, let's look at the next one. So the next one, we have 3 terms there. And again, we always look for a greatest common factor. And this time, there's no number that they all have in common, but they all have at least one p. So I'm going to factor a p out. So we left with p squared minus 12p plus 32. And now I want to look to see, can those 3 terms, can those be factored down further? Now this is one of those where, since our value for a here is 1, we can do that easy trick of just saying, well, we're going to have, put this back in blue, we're going to have p there in both of those places, but now we're looking to see what 2 numbers would multiply together to be 32 that would add together to be negative 12. So you want to start or work with the factors, or work through the factors of 32. Now the fact that they multiply together to be a positive number and they add together to be a negative number tells me that they both have to be negative, because a negative times a negative will be a positive. When you add those together, it'll be a negative still. Now, have you come up with what 2 factors multiply together to be a positive 32 that add together to be negative 12? Well, hopefully you're thinking negative 4 and negative 8. So negative 4 times negative 8 is positive 32, and negative 4 plus negative 8 is negative 12. So that would be the factored form for number 2. Let's look at number 3. So as we're going through these, they're just going to gradually get more and more challenging here. So with this one, again, I see that they all have at least an a in common. So I'm going to factor out an a. Now, it looks like they're also divisible by 5. By the way, little divisibility tests. Anytime a digit ends in 5 or 0, it's always divisible by 5. And so let's see what happens when we factor out 5a. So here we'd have 5a squared minus, and then to divide by, the next step would be to divide 80 by 5, and you'd get 16. So we'd have minus 16a. And then we would take 60 divided by 5, and that would give us, that would give us 12a. I'm sorry, 12, because we factored out an a. So we'd have 5a squared minus 16a plus 12 here. Oh boy. So this is one of those where we do not have an a value of 1. The trick that we did up here in this problem does not work if our a value is not 1. That is really important for you to remember. So we've been doing a lot of factoring recently where the a squared, the leading coefficient, has been just 1. That is not happening here. So now we have to go back to that box method. Let's review how to do that. Whoops. So remember what we're trying to do is we're trying to figure out what factors would go on the outside here. That's what we're trying to find. So the way that we set this up is we put that first term, which is 5a squared, in the top left corner. We put the last term, which is a positive 12, in the bottom right corner. Our goal is to figure out what goes in these two boxes. So we're trying to find two numbers that multiply together. So what we're going to do is we're going to multiply together the 5a squared and 12, so we get 60a squared. So we're trying to find two numbers that multiply together to be 60a squared that add together to be negative 16a. So can you figure that out? Two numbers that multiply together to be a positive, let's just focus on the numbers for right now. That two numbers that multiply together to be a positive 60 that add together to be a negative 16. Now the fact that they multiply together to be a positive and they add together to be a negative, it's very similar to the previous problem where they're both going to be negative. So hopefully you've come up with negative 6 and negative 10. Because negative 6 times negative 10 would be a positive 60, and negative 6 plus negative 10 would be negative 16. Now we're just going to put a's on there, because now they would get positive 60a squared and negative 16a. So if we put those in the box, again, it does not matter where we put them at. We can put them in either of these two places. But we'd have negative 6a and negative 10a. All right, so now what we're going to do is we are going to figure out the factors that go on the outside. So let's look at the rows. So if this first row here, the greatest common factor between 5a squared and negative 10a would be just 5a. Remember, if this first term, when we look at it from left to right, is negative, then this has to be a negative. And so between 6 and 12, it would just be 6. Would be our greatest common factor there. Now looking down, if the first term we see is positive, then it stays positive. So here, between 5a squared and 6a, the greatest common factor is just a. Or you could look at it as 5a times a is 5a squared. And negative 6 times a is negative 6a. All right, the last one again, since this first thing, when we look at from the top down, since the first item we see is negative, this has to be negative. And so between 10 and 12, the greatest common factor would be 2. And we could double check that because 5a times negative 2, sure enough, is negative 10a. And negative 6 times negative 2 is a positive 12. So our answer, our final answer would be, now don't forget about the 5a from the beginning. Don't forget about that. That's still part of our answer. And then we would have a minus 2 and 5a minus 6. It does not matter what order we put those in, as long as we have those as our factors. All right, I want you to try one on your own. I want you to try this next one because it's going to be very similar to the one that we just did. You're going to start by looking for a greatest common factor between 40, 30, and 16. Well, I should say 14r cubed, 30r squared, and 16r. You're going to find a greatest common factor first, just like we did in some of these other ones. And then I want you to factor that down further. So why don't you guys go ahead and pause this video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So let's start by finding the greatest common factor. So here the greatest common factor you should have found is 2r. So we're going to have a 2r that we factor out. So that would leave us with 7r squared minus 15r plus 8. All right, so now we're trying to figure out, so what we're going to do is we're going to multiply these together. Well, actually, let's go to the box. I always like to do the box first, just to get it all set up before we start getting into this nitty-gritty. All right, so we'd have 7r squared and positive 8 would go there. So again, we're trying to figure out what goes in the other two boxes. Okay, so now let's go back to the 7r squared and 8. When you multiply those together, we get 56r squared, and the middle term is negative 15r. So we're trying to find two numbers that multiply together to be a positive 56r squared that add together to be negative 15r. So hopefully you got negative 7r and negative 8r. Because if you multiply those together, we get a positive 56r squared. And if you add those together, we get negative 15r. It does not matter where we put those. And then when we go to find the greatest common factor for each row and column, you should have gotten that for one of the sides. And then in the other side, we'd have 7r and negative 8. Double check. R times 7r is 7r squared. R times negative 8 is negative 8r. Negative 1 times 7r is negative 7r. Negative 1 times negative 8 is a positive 8. So when we write our answer, you do not forget that greatest common factor from the beginning. That's still part of your answer. That's the one mistake that a lot of people forget. But that would be your answer. 2r times 7r minus 8 times r minus 1. Again, it does not matter if you switch the order of those factors. So if you had 2r times r minus 1 times 7r minus 8, it's the same thing. All right, let's look at number 5. Number 5, we have a difference of squares. How can I tell? Because we're subtracting, and I could take the square root of each of these terms and get a nice little integer. So for example, for the first part, if I take the square root of 9x squared, I get 3x. Okay, so in other words, if I square 3x, I would get 9x squared. And if I take the square root of 25y squared, I get 5y. So if I were to square 5y, I would get 25y squared. Now, why does this matter? Well, remember, let's think back to what a difference of squares was. This was back to chapter 3. We learned that if we had a squared minus b squared, that equals a plus b times a minus b. So if we could figure out what our values for a would be and what our value for b would be, we could just put it in this format. And that's what we just found. This is our a, this is our b. So when we put this in factored form, we would have 3x plus 5y and 3x minus 5y. The one thing I did forget to mention was we still want to look for a greatest common factor for these. And if we have one, factor one out. In this case, we do not have a greatest common factor. All right, let's look at number 6. Now, this is not a difference of two squares because we have an x cubed and a y cubed there. So this is actually a sum of two cubes. So we want to figure out what I would cube to get 108x cubed and what I'd cube to get 32y cubed. Now, you might be thinking to yourself, I don't know what I would cube to get 108 or what I would even cube to get 32. Well, that's because there's nothing you could cube to get those values. Because remember, what's your first step? Your first step is to always look for a greatest common factor. Now, you want to be careful. Yeah, both 108 and 32 are both divisible by 2, but let's just see what happens when we do that. If I factored out a 2 here, from 108, I'd get 54x cubed and 16y cubed. Well, still I'm stuck. Because what would I cube to get 54 and what would I cube to get 16? Well, I should notice that these are also still even. So 2 is not my greatest common factor. So just because we can find something that works doesn't mean it's always your greatest common factor. We always want to look to see what's the largest number that goes into both of these. And 4 is the greatest common factor. So then we're left with 27x cubed plus 8y cubed. Now this is factorable. This is a sum of, again, a sum of two cubes. So what we want to do is we want to figure out what would I cube to get 27x cubed, and what would I cube to get 8y cubed? All right, let's think about that. So have you thought about that? Have you figured it out? Well, 3 cubed is 27. So if I cube 3x, I would get 27x cubed. 2 cubed is 8. So if I cube 2y, it would give me 8y cubed. And why is that important? Well, remember, if we have a sum of two cubes, here's how that factors down. So remember, it's always going to be the same pattern of a and b and a squared, ab and b squared. And then we had that acronym, that SOAP acronym. Which means that it's going to be the same sign as what we had originally. And then we're going to have the opposite sign of what we had originally. And then it's always positive at the end. So that's the form that we're going to be putting it in. So now that we figured out what, because remember, a would be your 3x and b would be your 2y. So to factor this down, we would just say, well, we would have 3x plus 2y Then we would square our 3x. Now you got to be careful. We square both the 3 and the x, not just the 3 or not just the x. So we would have 9x squared. Then minus. Then we're going to multiply our a and b together. So we would take 3 times 2, which is 6. And we'd have xy. And then always positive. Then we would square the b value, which is 2y. When we do that, we get 4y squared. So that's how you would do that one. All right. Last one, I want you guys to take a minute, and I want you guys to do this one. This is a difference of 2 cubes, and it's going to be very similar to the previous one as far as the format, except for remember your SOAP acronym. So I'll just write this down over here. So when we go to factor this down, if it's a difference of 2 cubes, we would have a and b, and we would have a squared, ab, and b squared. So remember the process is the same. And then we have the SOAP acronym, same sign, opposite sign, always positive. So that's what you're going to use to factor number 7. So go ahead, pause this video, try that one on your own. Don't forget to look for a greatest common factor first, and then try that one on your own, and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So for this one, let's first start to figure out what our a and b values are. Well, actually, no, I almost forgot. Our greatest common factor, we got to start with that, because everything here is divisible by 2. So we end up getting x cubed minus 216y cubed. All right, so now what would I cube to get x cubed? Well, that would just be 3. And oh my goodness, I just remembered something from our previous one. Did you catch something that I forgot? Oh boy. You know what? Instead of editing this video, it's important for you to know that, hey, sometimes even we make mistakes. What did I forget from this final answer? I forgot my greatest common factor to include that. So we would have 4 in there. So we'd have 4. So that would be your final answer. 4 times all of that quantity. Whew, good thing I remembered. All right. So let's not forget that in this one. So let's not forget that we're going to have 2 as part of our final answer. So let me just write it like that even. Okay. So let's go back. And now we got to figure out, okay, so x is just our a value. So now we got to figure out, well, what would I cube to get 216y cubed? Well, obviously, we're going to have a y in there because y cubed would be y cubed. Well, what would I cube to get 216? Sometimes you have to do just trial and error if you don't have these memorized. And 6 cubed is 216. So we would have our a value is x, our b value is 6y. So when I go to set this up, it's going to be x minus our b value, which is 6y. Then we square the x, so x squared. They're going to multiply x times 6y. Now make sure you just put it in this order. So it would be plus 6xy. Don't say 6xy, that just looks weird. Always put the numbers first. So it would be 6xy. And then it's always positive. Then we square that last term, so it would be 36y squared. So again, don't forget that 2, like I did in my example previously. All right, so that's how you do number 7. So hopefully that clears up how to, or refreshes your memory, how to do some factoring. Because factoring, like I said, is a really important, it's an essential skill. It's something that you're going to be using a lot the rest of the semester in Algebra 2. And you're going to use it and need to know how to do this a lot when you get into pre-calculus. So please make sure you understand these concepts. Make sure you have this skill down. And if you don't, make sure you meet with me or your math teacher to figure out what it is that you're not quite getting.